and then a panel conversation. And I want to promise that I will deliver 10 a.m. If my panelists and keynote speakers comply. But we are agile, and so allow me invite our first keynote speaker, Professor Kala, who is going to speak to us. Now, there's one thing I've come to appreciate, so I won't read their bio. They all have very detailed LinkedIn profiles, so the challenge I have for you is go look them up on LinkedIn and get to know who they are. So Professor Kala, without wasting time, please come to the podium and speak to us, and we'll invite Deepa right after. Can we please welcome Professor Kala as he comes to speak to us? Over to you, Kala.
Good afternoon. Oh, sorry, my brain is not working. Good morning, everyone. And it's really a great pleasure for me to be here. I'm going to try and be a little bit quick. And I just want to give you a little bit of an overview of how I see things evolving in the digital space. It's a very light type of presentation, but it's based on some observations that I've seen. And I think, particularly for utilities in Africa and in South Asia, I think there's a lot of relevance in what we're seeing emerging. And I've already had discussions with some of the utilities from Africa about some of this. So when we talk about using digital, it's really to help the water sector get smarter. We have a lot of global change pressures that we're experiencing. And because of those global change pressures like climate change, but also rapid urbanization, we're struggling to manage our resources effectively using the current infrastructure. So we're starting to design our systems more smartly. They're becoming more adaptive to some of the uncertainties associated with global change. We're starting to look at more distributed systems because it allows us to support things like the circular economy approaches. So we're becoming much smarter by design. And the reason we're sort of designing systems more smartly is also because we have to use our resources more effectively. We're starting to rethink the way we use water, the way we reuse water, and even the way we use energy as well. We're trying to minimize our energy costs. And we're trying to also recover value from our waste streams. So we're getting smarter in the way in which we use resources. And all of this is really being supported by digital innovation. Digital innovation is really there as an enabler. It's not the end. It just facilitates us to do some of these clever things. Now, utilities worldwide are on this digital transformation journey, and Africa is no exception. And we've seen a growing adoption of digital tools to enhance the operational efficiencies. Things like SCADA for real-time monitoring, GIS is widely used, and Frank, who will be on the panel, is an expert in that. For asset management, we see the deployment of smart meters that allow us to manage our water losses more effectively and also improve revenue collection. And things like mobile payment systems, which are quite innovative here in Africa particularly, that really opens up service provision in a very effective way for people. So these advancements have really been making a significant impact here in Africa, but there are also challenges. And I don't really have time to go through some of those challenges, but I'm sure the panel will discuss that. Now, when you look at digital, you're really talking about an ecosystem. And that ecosystem starts with sensors that capture the data. And there's a lot of innovation in this space. Sensors are becoming smaller, they're becoming cheaper, and they can measure more things. And we're seeing a lot of water tech startups who are focusing on the development of sensors. And in Asia and Africa, you're seeing a lot of very frugal innovation, right? Cost-effective type of innovations. And you see people developing a battery of multi-parameter sensors that are cloud-enabled, and they can measure many, many different parameters, both in terms of water and wastewater. We're also seeing a variety of sort of in-pipe probes, sort of drones that get released into the water, and sewage pipes. And they're able to map the networks, they're able to check the integrity of the pipes and the condition of the pipes, and they're able to detect leaks and search for blockages. So this is a big area that you're seeing a lot of companies now developing these in-probe type of robotic-based sensors. So we're generating a lot more data now and a lot more variable type of data, right? The volume is increasing because the velocity at which we're measuring things is faster, and we're measuring a lot more things. And so we see quite a lot of evolution in terms of the way we process that data, both in terms of data processing, the modeling, and the visualization. And we're moving away from mechanistic models. My training was very much in sort of mechanistic models, which are based on the law of physics. But we're shifting from that to be looking more at data mining models, models that depend on a lot of data and really look for patterns. And in this respect, you see the application of AI, things like neural networks, for processing pressure and flow sensor signals, and trying to sort of proactively detect where a pipe might burst, where a leak might occur in advance of it happening. But a big area, I'm sure we all know, is the area of sort of deep learning, generative AI, and this will be very important to our sector, and I'll talk about that in a minute. So we generate all this data, we process this data, and now we're seeing the development or the emergence of smart devices, pumps and valves that sort of have onboard computers on them, and it's built into the devices themselves. And what all of this seems to be moving us to, it's not working. Okay, so what this seems to be moving us to is really what we would call silent running systems. So in the future, you know, these systems will self-manage and self-regulate themselves. So you see, as the cost of connectivity goes down very fast, water utilities have the opportunity to really reanimate their assets. They can bring them back to life and watch them like children, you know, as they perform, as they age, and as they deteriorate. So we have this opportunity to start to reanimate both our above-ground infrastructure, but also our underground infrastructure. For me, the most exciting development that I've seen in the last sort of 8 months is around generative AI, right? And I really think it's opening up a new dawn within our sector, particularly these large language models. You know, these systems are unleashing the potential of our untapped data by making complex analysis quite simple and accessible to everyone. Gone are the days when you will need a programmer to extract insights and data. Today, human language is the programming language, and all of us are empowered to be data analysts. I mean, really, anybody can do it. So these generative AIs, they seamlessly integrate data from different formats. So our monitoring data of pipe flows and pressures to the physical data in our asset management systems, which we call structured data, you know, our customer complaints in our CRN systems, which could be sort of verbal or voice, which is sort of more unstructured data. And then we have the hidden tacit knowledge of our experts and operators and repair teams. So these generative AIs can take the data in different formats, and you can just place them inside the generative AI, and then you can start asking questions, and it allows you to start to interrogate this huge amount of data in a very simple way. Now, when I think of the data that a utility has, I think about it like a library, right? And for me, a library is a gold mine. I'm an ex-academic. I love going to libraries and reading books. Many utilities, particularly in Asia and Africa, they only read a few books in the library, and the rest of the books are forgotten. You see, our sector collects a lot of data, but we rarely use most of that data, and we rarely connect the dots with that data. And a lot of this has to do with the sheer volume and complexity of the data, right? It overwhelms us. You see, we possess historical registries, handwritten logs, contractors' records dating back decades, documents which detail which pipes were laid when, by whom, and which pipes failed. So we have all this data, but we never really process it. So the problem is not the lack of data, it's the lack of using it. So what if we could transform that chaos into clarity? So let's zoom in onto the 15%. On average, utilities use about 15% of the data that they collect. And this is really the structured data, the low-hanging fruits of our digital resources. This is easy and clean to analyze. This might be real-time flow measurements captured by smart meters. It may be related to pump performance, customer billing data. And these data sets fuel our operational dashboards that you see a lot of utilities having, alerting them to immediate issues, usually when something's happened, right? So it's after the event, and then they react. So most of this data, this 15%, is used for reactive purposes. It tells us what's happened. You know, like a pipe has failed, there's been a change in flow, some pressure variation in the network, and then we respond. But we need to move away from reactive to becoming more proactive. We have to think about predictive management. So if we look at, if we look at the 85% of the unused data, this is the graveyard of missing opportunities. This isn't data that's useless. It's untapped, and its intelligence is waiting to be discovered. Now, it includes some structured data, maybe something related to flows from a reservoir or something, but it consists of a lot of unstructured data, like handwritten maintenance logs, contractor records that could expose poor patterns of workmanship or substandard materials that we use, customer complaints about smell or water quality, which has happened through, say, WhatsApp, emails from engineers flagging recurring issues. Consider this maintenance log might reveal, for example, that a specific pipe segment consistently fails every time there's a heavy rain. Losing this tacit knowledge is like losing a map in uncharted waters. Now imagine the power of preserving and harnessing this knowledge in our decision making. Because in the digital age, tacit knowledge is not just important, it's indispensable. And with these generative AIs, you can upload voice recordings when you're interviewing your staff, videos of the staff talking about some of the problems, and their handwritten notes. They can just be uploaded, and then you can start interrogating them. So this generative AI that I'm talking about, these large language models, right? You can feed them with your traditional structured data. But now you can just go to your offices take all the PDFs, take all of the handwritten records that you have. And you know, I come from Asia, and we love writing in books when the pipe was laid, and when we have masses of these volumes of encyclopedias of the history of the network. Those can now just be placed inside the large language model without much work. And then from that, the users, you, can just ask simple questions. You don't have to know anything about programming. You just put it in there, so it's got this domain of information that it's searching, so it won't hallucinate. And then you say, can you analyze this historical data and provide me a summary of the pipe materials with the most frequent breaks, including some trends. And so this machine will then start analyzing this information, looking for patterns, looking for trends, and then start sharing with you correlations, right? And it starts to share with you an understanding. I've put in to ChatGPT, for example, a 200-page document, and have been able to generate a one-page executive summary that was fairly accurate within seconds. We need to open them up and start feeding them into this. We need to open them up and start feeding them into this without doing much work, and then interrogating it, because it without doing much work, and then interrogating it, because it allows us to make effective decisions. Allows us to make effective decisions. And of course, if we can take some of that tacit information, if we speak to senior decision makers when they leave, if we interview them, if we try and get decision makers when they leave, if we interview them, if we try and capture some of their knowledge and understanding of the system, the pipe fitters, the people who replace valves, understand, their sort of deep knowledge of the system, then we can start to ask questions which are really related to their experience. We're doing a correlation. This is the power of these generative AIs. Now, my background was in water distribution, and I did a lot of work on optimization and
the smartest data science.
Welcome, Duali. I'll invite Professor Harsha Ratnawera, a professor of water technology in Norway. Welcome, Professor Harsha. I was trying to think of how I will hack this in 15 minutes. And this is what I'm going to do. So, from the keynote, a couple of things have emerged. But
data available in platform like this. So I want to stop here. Thank you.
Thank you very much, Dr. Kun. Professor, what's your take on this? Digital transformation, innovation, I mean, these are buzzwords, very easy to catch around in most of these conferences. But let's break it down. What does it actually mean?
I think still there is a long way to go to have the sufficient competence and capacities in our sector.
Okay.
Right? So I think the universities and the education system has quite a lot to do there, because we are preparing the future, tomorrow's leaders, engineers, and policymakers. So we need to start there, and that's why we are involved in reformatting, improving the curricula to integrate digital tools and digital technologies.
Thank you. So Frank, before I ask you a question, I received a notification from the Revenue Authority about 3 years ago, and the Revenue Authority was asking me to file for my rental income. And I'm like, God is amazing. I am being asked to file for rental. I really wish I had rentals. So I received notification, you need to be at the authority in today at 5. I received the email at 4. I received the email at 4:30. That's a story for another day. But I finally went to URA. And so the first question they asked me was, do you have 2 water meters? said no. So they told me we are using AI, GIS. And I looked at this person, I'm like, I understand what you're talking about, but let's not go there. I don't have, but then I found out that because I used my mobile number to pay for 2 water connections, that was the point. I come to you, Frank. Interoperability. DIPA is trying to build a vision for Africa, a vision for utilities that creates a platform around data sharing. But how do we start internally in terms of breaking the silos that finance and engineering and operations are reading from the same dashboard? Over to you, Frank.
Yeah, so thank you, Michael. First of all, a disclaimer. I had nothing to do with what your audio with your...
It has nothing to do with you, Frank.
Yes, so of course, as usual, as always, I am blown away by Kala's presentations. I've known him for a while now, because he brings things really to life. One of the things as he presented, now talking about interoperability, is it struck me that there are issues that use...
It might give people who don't know enough a bit of a false sense of confidence about very big decisions, very pivotal decisions. And the third issue is that AI is becoming weaponized in the world, and it represents a real risk to the sector. Be interested in what the panel thinks.
The final question here, right here. The lady over here.
My name is Naama Sharif. I'm coming from Brentwood, Germany. My question is, sometimes we win some tender or projects to build wastewater treatment plants in development countries, and we found sometimes that the treatment level we have to do is better than the river where the wastewater, treated wastewater discharge is. So sometimes we clean the water, the wastewater to very good level to discharge it in very dirty river. So we are industrial sector, we cannot wait to advise the local customer, but because we are making money. But what do you think this related to bad management, or what the kind of local issue is?
Okay, so this is how we're going to do it. Pick a question, so that's how we're going to run it. So I'll start from Deepa all the way to Frank. You had, I think, 2 questions, Deepa.
Yeah. Okay, I just need 45 minutes, and I'll talk about it. Okay, I think the first one's a really, Emily, thank you for that. I think words like data science is scary, right, for a lot of people, right? Because when you say it's like math or computer science, like, and utilities, I think it's not the comfort zone, right? It's really just about, and it's going to be a journey of learning by doing, and I think that's going to happen when you start working with these models, and you're starting to see how incredible this revolution is in terms of democratizing it beyond data scientists. So you don't have to be comfortable with data anymore to work with data. And I think, and you are never going to, and that is an experience. It's not something we can talk about, it's not something you just even can teach. I think it's a bit of a learning by doing, and I think I think that's going to be one of the things in the collaborative. We want to give utilities the experience of being able to work with that. Yeah. So I feel like that's my, on data quality, I would say, we're not even starting with any assessment, we're not making any judgment. We're like, give me what you have, we're going to look at the data you have, but you don't even know what quality data you have unless you've analyzed it. When we did this, for example, in Kenya, we realized that there were massive gaps in data quality, right? Like 2 different reports, and there were interoperability issues, but there were also very fundamental gaps in just how we were collecting data and the quality of the data that we were collecting. And we could show that the higher granularity data was relatively more reliable than the low frequency annual estimates that they were making. And we wouldn't have been able to even come to that point if we weren't analyzing the data in the first place. So in the beginning, we're saying that's okay. let's assume all of this is bad even, but let's get started, right? And let's look at what you have. Let's look at, and then it'll tell us a lot about the quality, and then you start thinking about how to improve quality over time. Great question on AI and how to be data ready for AI. It's actually not very complicated. It's just so you have data that comes in the form of image, text, or numbers. I'm going to keep it simple. And then you're simply labeling data in a way where the model understands it. So depending on what the use case is for the AI model, what you're starting to do is you're sort of creating data pipelines. So you're saying, okay, I need to collect data on customers, and that data is going to come from this operational workflow, which is a business workflow that the utility have. And you're taking the data that already exists on your software, but you're just labeling it so that it can speak to the AI model better. So it's not rocket science, even though I use the rocket analogy. There are very simple things that you can do, and there are ways we can support that. Risk. I'm happy to talk about that, but I'm also happy to let the other panelists take on that.
Yes, I think so, yeah.
I'm requesting that is given it. And we limit its search, right, to the information that we're giving it. So it doesn't hallucinate, it doesn't go into the web and start searching for stuff. And what it's enabling us to do is to do the things that we wished we could do ourselves, but we just don't have the time. And I see that in IWA. We would like to curate a really good summary of all the top papers on anaerobic digestion, but it takes a lot of time. And we found that if that we know have been peer reviewed and they're good, and we ask it to find the key findings from this, it does a pretty good job. And I was recently in Malaysia, and I saw that in the Philippines and in the PUB in Singapore, they had all of this historical data that no one had ever touched. And they got someone to just place it into a generative AI. And then they said, can you interrogate this? And like Deepa said, they found inconsistencies between certain types of consultants that they employed. They found inconsistencies in contractors that they were using in terms of the performance of certain pipes which were laid by different people. Things that they just never would